Uh, to wrap up SN1 and SN2, we have to also talk about a possible reaction known as elimination, meaning that if you are a primary haloalkane and if you are potassium hydroxide, sodium hydroxide dilute, your solvent is water, you go through SN2 reaction and you produce alcohol. That was substitution we studied. Now what happens if your solvent is changed and your ethanol, hot ethanol, like 60 degrees Celsius? Then you will go through elimination and you produce alkene. And also it's preferred for secondary and tertiary haloalkane. So I give you an example of a secondary one. I put bromine here. So I'm forming a propane that on the second carbon I have my halogen, so it's a secondary. And now I'm going to add it to hydroxide, potassium hydroxide, except I will put it in a solvent of ethanol. So solvent is ethanol, C2H5OH, and it's about 60 degrees Celsius. Now what happens is this hydroxide is going not to be a nucleophile, rather a base. So it's going to attack this hydrogen here. So it's a base, attacks the hydrogen. Now hydrogen will go with this OH to give you H2O, and the electron is going to collapse into this single bond. That polarizes bromine. Bromine travels with its own electron, and the leftover electron also collapses into this, and you produce an alkene. You have 2 hydrogen left on the last one, 1 hydrogen here, and you have your CH3. So now you have propene, it's 1 propene, and it's an elimination reaction, and usually this is E2. The rate of reaction depends on both species. So the rate is dependent on both haloalkane and the nucleophile. So you have your haloalkane and you also have your nucleophile. So this is elimination reaction. This is the only one that you might confront in IB, which is 2-bromopropane. If your solvent is alcohol, slow down. You're not going through substitution. You rather are going through elimination. So this is a final point on haloalkanes.